Hi there, welcome back. Welcome back to another installment of the Grundig Satellit 3400 series. And this video is one I've been particularly looking forward to, and I'm sure you have too. It's the FM. As you know, FM is actually fairly sensitive because I did realize I could hear some stations that were very far away, but the sound level was crappy. And I needed to sort that out, obviously. That's one of the main attractions of this radio is actually the FM. It's supposed to have really, really good FM. And the other thing I want to do is the completion of the alignment of the FM. So, you know, I did the AM alignment, the IF AM alignment last time. This time I want to do the FM IF alignment. Get that sorted out because I'm looking forward to doing the RF alignment as well. So in this video, what I hope to do is to somehow, hopefully, get the FM working. And then also, of course, do the FM alignment, the IF alignment. I'm not sure how much it needs because I don't know what I'm going to find when this thing starts working. I have faith. And so we'll take it as it goes. Hope you enjoy it. Stick around. Back to dismantle and chat. Let's see how we get this board out. This looks like it slides off those two guides over there. There's a connection to this ground down here through a cap. So we'll unscrew that. We take off this plug to the metering board or unit. So that's loose. There's a solder tag over here that I'll have to desolder. This looks just like a ground. We'll clean the solder in a second. Now this thing should come out. Just lifting, there's some clips on here. I'm just gently lifting the clips. I'm trying to pull it out. It looks like it came out of that one. And then it promptly went back in this side as well. Is that all it is? I love it when a plan comes together. So you see it's got a plug in there. This thing just came out. And it goes in those guides, and you've got that thing to solder back and this thing to put back and the socket to put back. Okay, I've reminded myself. Since I'm starting the clip like this, I think you know what's coming, don't you? 1 tantalum capacitor.
Ele é especialista na... Esta terça-feira...
See that? I love it. I love it. 1 bloody tantalum cap. And I took this out. I'll show you. It doesn't measure badly. It actually measures fine. Our FM is back. Bloody brilliant. AFC on, locks beautifully. Oh man, what a strange one. Let's see what this thing's like. So this is supposed to be 4.7 microfarads, and what we get there is 4.9. Doesn't look too bad, right? Okay. However, check for ESR. and I put it up to 100 kilohertz, which is where you should read ESRs, 4.88 ohms. Now, for a tantalum cap, that's extremely high. The only reason they use tantalum caps is because these things used to be very low ESR, and look at that. So what I've put in there is I've put in a very low ESR electrolytic, 4.7 microfarads, and that's the result. Oh man, this is where getting help from viewers and friends makes all the difference. Somebody had this problem. He's Stefan, he's got a channel as well. He had this problem and he warned me. He said, if you don't get FM, check out this capacitor. It does this, this, this. He told me exactly what it does. And I had that on mine. I took that out and it came back. It's exactly what happened. I could have been looking, I probably would have swapped it out anyway, but it's so much easier when you can get somebody else's experience and put it into effect and see the result. This is beautiful. Beautiful. I'm so happy. I'm going to have to do the alignment. That's how happy I am. We finished this section here. And just a note, this part here said at 500 millivolts input, IF curve must be adjusted with 11 without raising the base. I realized, and somebody pointed it out, that the base had risen too much, so I did make a small adjustment there. But if we follow on here, we've got the AM oscillator filter and aerial circuit. So this is the RF alignment, which I will be doing. Not that it probably needs it, but I like I just want to go through the process, make sure I understand everything. The other one is the drum tuner. There's a lot of stuff to adjust here. And then we get to adjusting the field strength meter, which you're supposed to do after you do the AM alignment, the complete AM alignment, so that's going to wait for a while. Alignment of the SSB, same story. But since we've got the FM working, this is the part I want to do. And before doing this, I did build this little circuit. It's basically an RF detector for the scope when you're trying to detect the envelope of the curves. And what they have here is you've got a germanium diode. This is the AA112. I think the one I've got is the 94 or something. Doesn't really make much difference as long as it's germanium. Even a Schottky diode would probably work here, but these are better. 200k resistors, one on each side. I've gone one step further. I've actually put a small capacitor, 1 nanofarad capacitor between here and here in parallel with that resistor. And it means that the curve doesn't have much RF on it, so it looks cleaner. That goes to the scope. And that is connected to the detection point. They've got a 0.3 picofarads. Now, 0.3 picofarads is actually rather strange, but it looks like one of those loose couplings again. And we will see that it basically is when we look at the board layout. So that's the first step. And now we follow instructions. So filter 9, measuring 0.304 via clip-on with built-in diode. So this is a clip-on with a probe with built-in diode, so that circuit to measuring 0.305. And it seems we leave it at measuring 0.305 for quite a while. All these tests here are done on measuring 0.305. You detune B and you do A for max, all those for max. And at some point you remove it. You actually go into that connector to the counter circuit and you feed it in there. And you have I and K for max. We'll get to this one in a second. This is really to redo that detuning that we did, okay? So we've got to worry about two stages here. First of all, if we look at the schematic, we'll go to the end here and see where the points are. And it does make sense. This B is actually the discriminator tuning. This is the one that you've got to balance to get a perfect low distortion wave or signal coming out. So they tell us to detune this first. And this is so that all the rest can be tuned without the effect of this part of the circuit on there. So there won't be any sort of loading on there. Your test points are here, 305, your detection point. And the first thing you do is you adjust A for a maximum when you feed your signal into here. So you're basically doing it the same way as we did the AM. You're going one step back and you tune the circuits. Then you leave your detection here. You move from measuring 0.304 to measuring 0.303, which is over here, and you adjust C and D. Then you go back one more and you put your signal into measuring 0.302 and you adjust E and F, and then you go to measuring 0.301 and you adjust G and H. Now what you're doing is exactly the same as with the AM. And the one thing you've got to be careful about is you've got to be careful about the amplitudes. As you can see, between this point and, where were we? That point, there are a lot of transistors. These are all RF amplifiers. So whatever amplitude you need to inject in here to see a response on this point will have to be reduced when you inject it in here because it's got another amplification stage. And the same thing applies when you go back to this point, you've got another amplification stage. So we really have to start low and see what amplitudes we need to see a nice curve. Now, there's one thing that I noticed. These two, this B and A, and this measuring point are all within that, you see that internal dotted line, dashed line? This is a shield. There's another shield on the other side. There's that shield there as well. So whatever we have to adjust in here, we have to sort of look for very carefully. But let's look at the board itself. And this is the FM board. This is the solder side. And what we're looking at when we look at that board on the radio is actually we are seeing the solder side. This is good. However, there's one thing wrong with this. This is sort of the other way around. So what I do here is I rotate clockwise once, rotate clockwise twice, and what I'm left with here now is the board as I see it. When I look at it from the back, I've got that small shield over here, and I've got that bigger, flatter shield over here. And so this is a lot easier to figure out where things are. And this is where the challenge came in. You see, you got a shield on this side, and there's measuring point 305. I didn't know where that one was. I will show you, it's difficult. You can see it through the top of the shield. I did not want to desolder the shield from here because the tuning would be off. So you have to sort of figure out where it is, and you can actually see it. If you look into that hole, you can see this pad is a particular shape. Now, once again, this is that light coupling. This is like a capacitive coupling pad. From there to there or to wherever it's supposed to be getting the signal, which would be here, this is probably 0.3 picofarads. That's what they talk about on that little circuit for the detector. So that's where I connected to. I actually soldered a little wire in there that sticks up the top, and I'll show you that when we get to it. So the first one we have to do is detune this guy, and you can see that from the underside, and you have to adjust that for max. Then your measuring point, your injection point is over here, MP304. Then you go back and you've got MP303 and you adjust those two. So what I decided to do is actually to identify all these measuring points. There's another one there, and that's 302, and there's another one here, 301. I decided to identify all these measuring points and solder little wires up there because these don't have any points you can connect your clip to. And it also makes it easier to see. So what you're going to see when I show you the board itself is a little wire coming out of that shield, which is for this guy here. Another wire coming out, where are you? Here, another one here, another one here, and another one here. Now with those wires in place, I can identify very easily, and it makes sense. When you inject in here, you adjust that one. When you inject in here, you adjust those two. When you inject in here, you adjust those two. And when you inject the top here, you adjust those two. And then we've still got that one there. I don't remember where you inject to get that, but I'll get to that as soon as I've shown you how we do this one. And again, what we see here is they tell us that it's FM depressed and AFC off, automatic frequency control is off, and it's IF alignment for 10.7 megahertz. And they do tell us that the wobulator output is connected. So this is a sweep. And what I'm going to do is I set the sweep to about about span of 200. So starting at 200 below, 200 kilohertz below, 200 kilohertz above. So it's a span of about 400 kilohertz. I might even do a bit more to start off with. And I want to see what the curve looks like before I even start adjusting. Here's that IF can with measuring point 305. Here's measuring point 301, or rather 304, 303, 302, 301. As you can see, that measuring point 305 is inside the can. I looked in through the top, I shone a little torch through there, and I could actually see that shape of that pad, so I just dropped a bit of solder, solder that little wire in, and then I can connect the probe to it. And there's no magic here. Here's the probe built on a little bit of PCB. There's the diode. And just follow that circuit. I put a BNC connector on here. I've got a little rigid wire on here, and I've soldered that. This is the probe itself, the tip. Soldered that to that point, so we're now measuring that point all the time. This stays here for quite a while. The probe has also got a ground, so I've connected that to an appropriate ground over there. Signal generator signal is connected to ground, and it's connected here to measuring point 304. As you can see, those little yellow stickies sticking out there, the little wires, make it a lot easier for us to find them. We can always then just desolder them at the end and clean up the solder with some solder wick. Makes things a hell of a lot easier. And now, what do we have coming in here? The signal generator is bringing in a sweep that starts at, I think I've got a span of 600. So the center frequency is 10.7. I'm starting at 10.4 and ending up at 11. Is that right? I'm just checking this. No, I've got a span of 400. I start at 10.5. I stop at 10.9. And I'm doing this in 280 milliseconds. I want to talk about that time in a second. I may have to increase that span a bit because I'm sending the signal in here and there's only one filter stage. So there isn't much happening there. But let's have a look at the scope. We've got absolutely nothing. I'm sending the signal into this first filter. It's a very low amplitude signal, so I'm going to increase that, see if we see anything. Yeah, we can see a little bit, not much. Let me increase that a bit more. And a bit more, and a bit more. It's at 400 millivolts, 500 millivolts. But the curve is not really distinct. So what I'm going to do is I'm going to increase the span of this to about 1 megahertz. Because we've only got one filter and it's slap bang in the middle. This is really in the middle. I don't know whether I want to change that. That is as good as it gets. Huh. I'm not changing that. I'm going to move back one step. I'm going to decrease the amplitude about tenfold, 50 millivolts, see what happens. Okay, it's there. It's not that strong. Go up. Okay, let me change the span now. From 1 megahertz, I'm going to make it 600 kilohertz. It's sort of there. There's one thing I want to do, and that is to change the time, because I've got a feeling this thing shifts it if I make it too fast. I'm going to make this, let's go to 1.4 seconds. Change the time base and see where we are. That's pretty close. That is pretty close. Let me try, which ones am I doing? These guys here. Let me try and adjust that a bit. It's sort of shifted to the left somewhat, but it's dropped the amplitude a bit. In fact, what I'm going to do is I'm going to put it on 700, which is a little bit more manageable. It refreshes faster, so you can actually see what you're doing. But you see, it's actually shifted a bit to the right, so what I need to take into consideration is that the center is not quite 10.7. There's a time delay there, a reaction delay, so I've got to be careful. Well, that sort of brought it in. That would be sort of ideal. Let's try 1.4 again. That's pretty good. That's good. I'm going to leave it there and go one back. Very little adjustments being done on here, which is a good thing. So I'm going to make that sort of 10 millivolts. I don't know what I need, but I'll adjust as needed. Now that is 10 millivolts. Let me take that up a bit. That's a very, very good curve. That's a very, very good curve. And that is here. No, I've just messed it up. That's what it was. Wish you could do delete or undo in these things, like you do in software. That curve is very, very good as it is. I'm not changing it. I'm just going to put it back a little bit to where it was. I think that's where was it? There. Good. I'm going one back. Again, I'm going to reduce the amplitude to the minimum. As I said, I don't know what I need. And we'll go back to here. Ah, good. Okay, let me give it just a bit more. Yeah, that looks good. Now I will adjust this guy here. That's a very, very good curve there. Can I improve it at all? I'm not sure that I can, so I'll just give it a try very gently. Rolling the wrong way. That's spot on. That is spot on. Let's try the back one. Reduced it, raised it, and raised it, and moved it away. Let's see if I can move it back. No, wrong way. Now, you know what? That was good as it was. Back, try and flatten it a bit. Yeah, and then I think I can shift this to the right just a smidge. Wrong way. There. That, my friends, is bloody nice. That is a nice curve with a very slow sweep rate, so we know that it's getting time to adjust. And I think that's it on these adjustment points. Let's see what else we need to do. So what have we done? We did that, we did that, we did that. And we injected the wobulator at, well, we clipped this guy on here as instructed. So we can do that. And we inserted the wobulator into 304. We detuned B and we adjusted A for maximum. That one really didn't need any. Then we went to 303 and we adjusted C and D, and we went to 302, E and F, and we went to 301, G and H. Now what do they tell us to do? They say FM counter connection cable. Right, so you connect your cable. Your insertion point now becomes that socket, that plug thing that goes into the counter, into the frequency counter. Okay, so I don't need to solder anything on there. And you do I and K for maximum, and you're still reading in the same spot. Okay, let's find out where I and K are. There's I and there's K. Now, I is outside the can, and I don't know how to get to it, and K is inside the can. Another can of worms. Let's see on the board what that looks like. There's K and there's I. Now, how do I get to these guys? I'll have to see on the board. It's right at the back. These guys here, this one, this one, this one, this one, I got through from the underside. Screwdriver can sort of lean in and get to it. But this, I'm not sure. I'll have to see. Okay. Well, let's have a look. This is what we've got. we've got the one transformer there with no hole through the top, and another one is here with no hole through the top, and there's no way I can reach it through the bottom. But what I did do is I injected a signal as instructed into that plug, the one that goes to the frequency counter. And let me show you what I get. Look at this. You know what? I'm not going to risk opening the can, removing the board and all that jazz when I'm getting that. That to me is good enough. So as far as I'm concerned, that one is fine. Sometimes you've just got to consider yourself lucky that it's perfect and no mess around with it. All right, next thing we need to do is we need to inject wobulator at 304. 304 is that first one that we did. And we connect to 306. Haven't seen this one before. And at approximately 10 millivolts on the base of T308, MP304 at the base, 10 millivolts on the base of T308. That's strange because that there is not the base of T308. And a very small deviation. The secondary circuit B is adjusted for optimum symmetry and straight curve, and the primary circuit A is corrected for maximum steepness. The moment at which the transformer curve passes through zero must coincide with the maximum reading on the instrument. We're on this side again, and we're talking about injecting here, and they say the base of T308, the base of T308 is, it's on there. So how can you inject in here and know that it's 10 millivolts on the base of T308? That's the part I don't understand. And your measuring point is that guy there, which is again visible sort of through the top of the can. That one's going to be a bit tough. Anyway, let's try it. Okay, I have a failure to report. I can't figure out what it is I'm supposed to measure there. I can't even figure out what it is I'm supposed to inject here. I tried a few things. I get nothing that makes sense. So what I've done is I've reverted to my faithful alignment or balance technique for that discriminator. And what I'm going to do, what I've done is I've injected a 10.7 megahertz signal, and I'm injecting it there, and I'm modulating it with an audio tone. I've got, 600 hertz at 50 kilohertz deviation. And I'm going to adjust this thing till I get a pure sine wave on the screen. See what happens. This thing is anything like what I expect it to be. We should be good. Oh, what happens the other way? Whoa, whoa, whoa. What is happening here? Well, I'm getting an optimum sort of here. That's a perfect sine wave. And what that tells me is that, I don't even know if I want to play with A. That tells me that whatever's being transmitted on the FM band that this thing's picking up, this discriminator is perfectly balanced. And what I'm going to do now is I'm going to leave it like that for now. I'm going to consider it done. I'm going to test it. And if it sounds great, then it is great. All right. Next thing I need to do is desolder these things and clean this all up and then see what we've got. So what have we got? Well, we've sort of done that, and I'm happy with the result. But there is one more thing, and that is this guy here, AM suppression. What this means is that the circuit that's doing the FM discrimination or detection is also programmed, or it works that way, that it suppresses any AM deflections. The whole idea is that you only want to look at the change in frequency and not the change in amplitude when you're receiving a station. And there's a way of reducing that, and there's an easy way of testing that. They don't tell you how to do that here, but I'll show you. It says the AM suppression is adjusted with control R381, which is a 2.5K pot. Very simple. It's over here. And if you look at the way this thing is done, you've got the two diodes, one there, one there. And when you're adjusting B, you're basically balancing that coil over there so that the signal arriving here to be, let's call it rectified, if you want to call it that, on this coil is at the same position relative to each other. Then we also have a resistor over here of 820 ohms. And because those diodes may not be exactly the same, they add a trim pot here. And what this means is that if you inject, remember this circuit is only going to pass through 10.7 megahertz carrier. Now that carrier can be amplitude modulated. Normally it's FM modulated. You put a 1 kilohertz tone on it, FM modulated on the carrier. But you can also put a 1 kilohertz AM modulated on the carrier. And the whole idea of this pot is that you test that. You send a 1 kilohertz tone on the carrier, you listen to it at the speaker, and you'll hear it pretty dim, pretty low, or it should be pretty low, nothing like the FM one. And then you adjust this trim pot till you get the smallest amount possible. And that trim pot is over here. It's pretty easy. It's accessible from the back. It's inside that metal can, that shield, but it is accessible from the back. So we'll just set that up. What we have at the moment is that FM signal coming in. The carrier is carrying a 1 kilohertz tone, which is the one we're seeing on the scope right now. It's FM modulated, and it's pretty good amplitude over there. Now, obviously, because I'm looking at the output, I can change the volume control. That's doing that. But I've got the volume on max. Now I'm going to go to the modulation, and instead of type FM, I'm going to go type AM. And now I've got AM modulation, depth of 30%, AM frequency is 1 kilohertz, the same as before. And as you can see, it's sort of disappeared from the scope. If I change this to speaker, I can hear it. I'm using the benchtop speaker at the top there, but I want to see it on the scope. Let's see. Change the... It's a very small signal. Very small signal, having problems triggering. If I take off the modulation, disappears. Put it on, it's there. Okay? Now watch this. Putting my screwdriver in here. Going counterclockwise. It's getting bigger. Okay, now if I go the other way, comes down, that's as small as it seems to get, and then it goes up again. Okay, so this is where I want to leave it. There, that's the smallest it's going to be, and it was not bad to start off with, but now we've done the AM suppression. And I think that's the alignment done. Let's just do some testing, see what the sound is like. We've got this all set up. I've got an antenna connected. And the sound reception is brilliant.
You understand? We were good fellas, wise guys. Bons rapazes.
São classic flip. Vou usar assim em dobro, não sei, mas pronto. Tem aqui uma coisa, uma bolsa de mãe. Sempre tem uma chupeta a sair, alguma coisa. Mas pronto.
Here's a station that I normally don't pick up. This station is on a 100.0 and I normally can't pick it up. Amazing, amazing. FM is done, and I'm happy to say this alignment was not half as scary as I thought it would be. I certainly hope it serves to help you tweak yours if you have one of these, and especially to get the courage up to do it. I mean, what could go wrong? You could blow this thing up. Hey, happens. Okay, once again, that's another stage done. And I'm going to have a look at the instructions. There's quite a few little things that I need to adjust. The BFO for one, the counter, I believe, has some adjustments as well. And I also want to do the full RF alignment for the experience of it. And that'll come probably next. So for now, I just want to thank you for your company. Hope you've enjoyed this. Hope you've got something from it. Please feel free to leave comments down below. Always appreciate them. I do read them and I do respond to most of them. And if you've enjoyed this, click like, share, subscribe, and all that jazz. And I'll see you again soon for the next installment. Thanks for watching. Bye for now and stay safe.